code that we use through PowerShell to actually make the FFUs. But for those of you that don't know what I'm talking about here, FFUs are full flash update files. So think of them kind of like WIM files, and we'll explain all of this as we go through the presentation. But just think of this as a way to speed up your imaging process compared to what you might be doing today. And so this presentation is going to basically just go into how do we speed up the deployment of Windows using FFUs. So we'll go through what FFUs are, why do this, because we already have imaging solutions, right? We have MDT, we have SCCM, we have various other community solutions, like why this versus anything else. And then we'll obviously go through how to create them and then how to deploy them and all the different prereqs. So what are they? As I mentioned earlier, an FFU is just a full flash update file. It's just got an FFU extension. It's very similar to a WIM file, actually. You can use DISM to modify them. So if you needed to mount an FFU, you can mount it using DISM, using the same commands. And then you can service that by adding file, if you wanted to add updates and things like that as well. Hearing some, Scott, can you check to see if there's anyone unmuted? That sounds better. And when we introduced FFUs, this actually was introduced back in the Windows Mobile, Windows Phone days. This was something that was designed primarily for incorporating mobile imaging as opposed to desktop. But then when Windows 10 came along, we converged the code from mobile and desktop using something called OneCore. And by doing that, it allowed for desktops to also use FFU files for imaging. Now, the difference between WIM and FFU is that an FFU is a sector-based copy of a disk. So if you had a physical laptop and you wanted to clone it, you could use DISM to, you boot to PE, run DISM. You could clone the disk by creating an FFU file of that disk. And it would be the exact same copy of like the first day you got the hardware. If you copied that FFU off and then you wanted to deploy it again, it'd be just like the first day. Whereas with a WIM file, that's file-based, and so you'll create a image that is copying files effectively. Think of the WIM as more of like a zip file, and when you create that WIM file using DISM, we're effectively just copying the Windows installation files, and there could be other partitions as well. But we're copying that, and we're doing it in a file-based method. So between file-based and sector-based is always going to be faster. Now, FFUs, like I just mentioned, are typically faster to capture and deploy than WIM files. However, what's really interesting lately, and this hasn't been the case in the last few years, and I don't know if there's something that has changed in Windows 11 or any recent releases of Windows, but it seems like the install ESD files that you can download if you use like the media creation tool, and you have it build media for you, it'll actually give you an install.esd, which is similar to a WIM, but it's smaller. It's an encrypted file that is about a gig smaller than your install WIM file. So if you look at an install WIM today, it's about 4.9 gigs is what I looked at the other day. An install.esd might actually be about 3.9. So those are smaller, but they actually do seem to deploy pretty quick compared to what it used to be a few years back. So things are getting faster even on the ESD/WIM side of things. But you'll see though why we still prefer to use the FFUs here in a minute. So why do we do this? So you guys have probably used, most of you probably use Config Manager. Most have probably also used MDT. But there's also community solutions like OSD Cloud and WimWich. And so we've got imaging solutions. We've been doing imaging for a long time. Why go this route? Well, speed is one reason. When we initially started our Intune journey back in like 2015, 2016, myself, Scott, and a bunch of other folks were traveling out to customer sites, and customers have 500, 1,000 laptops sitting in a warehouse, and we needed to re-image all of them because something wasn't working right, or they had an old build of Windows. There's just some reason where we had to reinstall Windows. And so we were using WIM files and we were deploying using like auto unattend XML files, because you have to think that a lot of these customers that we were working with didn't have SCCM. So they weren't doing any imaging over the network. They weren't using WDS or any of that kind of stuff. So we needed to image these things with USB drives, and doing it through like an auto unattend or an unattend XML, we found that the process was slow. And as we started to look at other solutions, we came across FFU. And when we came across this, we had noticed that that deploying FFU files was significantly faster, and we could put Office, we could put other things in, and the deployments of these like 500,000, even like tens of thousands of devices that we were doing, we were finding that the speed was significantly faster than doing it any other way. Now, that's not to say that you can't use SCCM, you can't use MDT. Like, these tools are still there. MDT, we can argue that Windows 11 support isn't actually officially there. It's kind of tells you that the writing's on the wall for MDT to most likely not be something that we're going to support very long here. And so, with the way that things have been going for us, at least, we've just found that FFU has actually been faster. And so what we're finding is for an FFU copy of Windows and Office, it takes about 90 to 120 seconds, so about a minute and a half, 2 minutes, to copy the FFU file, just the FFU itself, the contents of the FFU, lay that down to disk, takes about 90 seconds to 2 minutes. And that's with Windows and Office. And so once that's copied, the USB drive can then be moved to another machine. So you can keep your USB drive in for a couple minutes, take it out, move it to the next machine. So if you're doing tons of devices, we've got partners in the warehouse. These are our device distributor partners. They use this method on tens of thousands of devices, and they found that it's super easy, it's fast. Yeah, you've got to have a bunch of USB drives. That could be a little annoying. We do have one partner that actually integrated this. I actually have a customer, I think, that integrated this process with WDS, and they've got their own boot, and they actually use the boot image that we provide, and they have an FFU that it goes and grabs off the network. So you could use WDS for this. We don't particularly do that, only because the customers that we work with, we don't know if they've got network-based imaging solutions or if they just want to do it via USB. And in this process, you can also include third-party apps. So like I mentioned, Office, but we also have customers that have deployed content filters. They've deployed Chrome, other browsers, VPN clients, all sorts of stuff. And so that's all included as well. But what's also interesting about this is that we can incorporate things like naming and create a process that makes applying drivers in a somewhat dynamic state fairly easy, as well as provisioning packages. And we're going to go through all of that here in a minute. And what we're also finding this is great for is scenarios that are low bandwidth. So we also do work, or at least I do work outside of the US as well. And so I've partnered with some of our folks in India. And in India, there's a lot of schools that have like no bandwidth at all. Very, very, very poor bandwidth. But they need to have, but they still leverage Intune, they still leverage Autopilot, they're still joining the devices to Azure AD. But when they're doing, either dozens, hundreds, or thousands of devices, they really can't allow for Intune to deploy Office, for instance. Like if Office is going to be like a 2 to 3 gig download, there's just no way that they're going to be able to download something like that for many devices. And so we need to basically make a thick image that's going to have their apps in it. But speaking of thick images, though, this is not something that is here to prove whether thick, thin, hybrid imaging approaches, like which is better. This was designed primarily for a large-scale deployment use case. However, what we found is that even IT admins have been giving like these USB drives to their technicians or even to some teachers. And in situations where a device just breaks, like the student's using something and just Windows isn't working, they can't boot, whatever, they just give them the USB drive, they boot off the USB stick, it's completely unattended. They don't have to touch anything. The device just images. If you're using provisioning packages, the package applies automatically. If you're using Autopilot, the student just signs in, or if you use self-deploy, you don't even have to touch the device until the logon screen. You get right to where you need to be. And so even in small scale deployments, people use this as well. So again, it's not an argument for talking about should we only have thin images and just deploy everything via task sequence or something from the cloud. A lot of it just depends on use case. And as I mentioned, lots of partners and large scale customers are using the process today. So if you wanted to create your own, and you tried to do this on your own, you can click the link. Well, you guys can't do it right now because I'm sharing my desktop, but when you have access to the deck, you can click the link. That'll take you to where you can go and actually do this on your own. But the tool I'm going to read on this is you basically build a reference machine. You could just take a device out of the box, boot it to Windows PE, just have a USB stick that has PE on it, and then run DISM, and then run the command line that I've got here. And that would make an FFU file for you. But that's it. It's just going to give you a point in time cut of whatever machine that you are trying to build an FFU from. Not really all that dynamic. And then if you wanted to optimize it and you wanted to deploy that FFU to something else, then you can optimize it using DISM/optimize FFU. However, that switch, that optimize FFU switch, what that's actually doing is it's making it so that FFU file can go onto any hard drive size. So with sector-based copying, if you make an FFU of a machine that has a 128 gig hard drive, you can only deploy that to anything that is 128 gigs or greater. But when you look at the OS, it's only going to show up as a 128 gig disk. So if you had a 256 gig destination machine, you would only get 128 gigs of space on it because the FFU that you copied, the device you copied it from, was 128 gigs. So the optimize FFU switch, what that does is it says, hey, FFU, we don't care about the disk size here. If we deploy this thing to a 256 gig disk, then it's going to be 200. You'll end up with 250 gigs of space showing up in File Explorer. So optimizing the FFU is very important. However, you're going to come to find that switch has been broken ever since the switch was released, and we're going to explain right now how we fixed that and how we can actually create these FFUs to make them a little bit more dynamic. So what we've done is like I mentioned, we've wrote some code. It's just PowerShell. So if you wanted to modify it, fork it, do whatever you want to it, feel free. We've got people that are doing that already. But what the prereqs are to do this is because the optimize FFU was broken for so long, they fixed it in the Windows, the upcoming release of Windows that's going to be coming out this fall. Those builds are actually like 25, XXX, so 25,000. In that build branch, that's where they implemented the fix for optimize FFU. And so that fix is actually in the Windows Insider ADK right now. However, you guys don't have access to the 25,000 branch unless you are on the Windows Insider preview. And so what we've had to do in the code is that we've effectively made it so that we're using DISM from the Windows Insider ADK in order to leverage optimize FFU. So you need to download the Windows Insider ADK and the Windows PE from there. And this is only going to be necessary until Windows ADK 23H2 is released, and it should be soon. In fact, a year ago this week, we released the Windows 11 22H2 ADK. So I was really hoping that I'd get it this week and we could modify the code and say, you know what, we don't have to worry about some of this flight test signing stuff that I'm about to talk about here in a second. But it's not out yet. So I'm hoping, and I've got a question out to our ADK team to see when this is going to actually hit the public sites. But typically we release the ADK when Windows goes RTM. And so when Windows goes RTM, it's typically in the summertime to get it to the OEMs. So that way they can ship devices in the fall for holiday. But the build has to be done by the summer in order for OEMs to get it. And so once the build is done, then the ADK can go out, the SDK can go out, and there's a hardware driver kit that also goes out as well. So there's a bunch of kits that get released around this time of year. And so I was hoping we'd have it now. We don't quite yet. Hopefully it shouldn't push too much further into June, but once that comes out, then you won't need the Insider ADK. You would just use the regular Windows ADK 23H2. And then also once Windows 23 H2 is released, which should be in the fall time, then DISM is going to be updated. The optimized FFU fix will actually be in box Windows. And so once that's there, then you would just use the inbox DISM. You don't even have to worry about having the ADK installed. You would need the Windows PE stuff, but you could still use just the regular inbox DISM. So this complicates things a little bit right now, but it's going to get easier here, hopefully in a month, and then it'll be much easier once we get to the fall timeframe when 23H2 is released for Windows 11. Now, the next bullet point here, flight and test signing. So this must be enabled. In order for you to use the Windows Insider ADK, you need to enable flight and test signing. In order to do that, you just run bcd edit/test and then test signing on. However, when you try to run that, if Secure Boot is enabled on your machine, which it probably is, and it should be if it's not, then you're going to get an error message saying that Secure Boot is preventing you from turning test signing on. And so you would need to disable Secure Boot, reboot, and then turn on test signing. So you'd run bcd edit/test signing. This is all documented in a much better way than a PowerPoint slide. And so in the docs, there's more details there on how to do that, what to look for. I got screenshots and stuff like that. But again, this is only required until the ADK for 23H2 is officially released, because in order to run that, you don't need test signing turned on. But if you're trying to run the ADK on just a regular Windows 11 machine, and it's the Insider ADK, then you'll get errors when you're trying to run DISM. It'll tell you there's some signing errors that'll come up that will prevent you from doing anything to modify the images. And so as an alternative to the second piece of this is that if you're on a Windows Insider build, so if you're running like Canary or Dev or any of the Windows Insider channels, flight signing should be enabled. You can run bcd edit and then look for flight signing. It should say flight signing is yes. And that means that flight signing is on. And so if it's on, then you should be able to run the Windows Insider ADK, no problems. And so look for that. Now, once you have created the, actually, I'm going to skip this one. I'm going to go back to drivers for a sec. Once you've got the ADK installed, you've got PE installed, and all that is configured, the media is important. What media you use is very important here, because most of you are probably used to just going to volume licensing, just going to download media from VLSC, and then you run your, either a Mac or you use KMS to do the activation. But if you use subscription activation, you've probably found that if you've imaged a machine, the machine may not actually activate. It may upgrade to like Windows Enterprise or Windows Education, but it doesn't actually activate. And if you've ever run into this situation and it didn't make any sense to you, this will explain it. So the media creation tool provides you consumer media. When you buy a device from an OEM, that media is actually consumer media. More often than not, it's going to be consumer media. There might be some corner case where they might use like some VL media, but in most cases, it should be an OEM installation of Pro. It could be Pro Education, it could be home, but in most cases, it's a consumer OEM, not a device, but a consumer OEM media is what you're going to have on that machine. And so in subscription activation, how that works is that the activation is actually done during UBI, or really early on in the process of that device turning on and connecting to the internet. And once it's connected to the internet, it's going to go to the activation service for Microsoft, and it's going to activate Windows. Subscription activation has not even come into play at this point. We just literally just activated with the key that's in the firmware of the device, and we match that up to the media that it's installed with. So if the key in the firmware is Pro, and you've got consumer media that's installed on that machine, you are going to activate. Activation will be successful. Now, in order to upgrade to Enterprise or Education, someone has to sign into that machine with an Azure Active Directory account, and that account is going to have a license associated with it for Windows 10 Enterprise or Windows 11 Enterprise. When that happens and that person signs in, that's when we upgrade you to Enterprise or Education. So if you go through this process and you use VL Media, but you don't pass a product key to do the activation, or you don't have KMS and the machine can't talk to the KMS server, then you're going to find that activation is going to fail, and things, you just won't have an activated machine. You'll have it, it'll be on enterprise, it'll be on education, or whatever SKU you're trying to deploy with VL media. It just won't be activated. So if your idea is to use subscription activation and get away from KMS and get away from Mac keys, then you want to make sure that you're using consumer media. And so to get that media, you can actually download it from the media creation tool. That tool will provide you with a consumer ISO, and then that ISO can be used. And alternatively, you can also download consumer media from the Visual Studio Downloads portal. So if you have access to Visual Studio Downloads, you can go ahead and get it from there. Now, if you're using the media creation tool, you will end up with an ISO, and that ISO might have an ESD or an install win. If you use the Windows 10 media creation tool media, it will create an install.esd. Doesn't matter if it's an ESD or a WIM file that your ISO has. The script is able to just parse that, and it works just fine. And then also, just for those that may not be aware, we release refreshed media to both the media creation tool, to VLSC, to Visual Studio Downloads. I've noticed it's always Tuesdays, but just this past month, I looked in May, and it was actually on Monday. So looks like Monday or Tuesday is when we refresh media. And I even validated the media creation tool media last week, and it was completely up to date with the May updates. So you can go grab your media from there. Now go back to drivers. For your drivers, there's a folder that we're going to create, and I'm going to show you this here in a minute in the demo. But there's a drivers folder that gets created, and it's going to be empty. If you want to include drivers into your FFU, you would copy the drivers directly to that folder. I recommend you only include drivers if that FFU is going to be used for a specific model. So what we're doing a lot of imaging now for are Surface Laptop Go's, Laptop Go 2s. And so in my drivers folder, I have a subfolder called Surface Laptop Go 2, and inside of that folder are all the drivers. I don't recommend putting multiple models in this because you end up with just a bloated driver store at the end of the day, because we're going to use DISM, we're going to copy the drivers into your installation of Windows. And if you've got 10 different models in there, you're going to end up with probably, 10 gigs worth of drivers that are added to your FFU that you don't need. And so if you want to deal with multiple models with your FFU, I know a lot of you are doing this with the USB drive. You can create a drivers folder on the USB drive, and then put different subfolders inside of that. So you might have like Surface Book, Surface Laptop Go. You could have some OEM devices like Dell, HP, Lenovo, whatever it might be. You can put individual folders in there, and I'll show you guys that here in the demo as we get to there. And then apps. So there's a folder in your development folder called apps, and that's where you can create a subfolder in there for all of the different applications you want to install. And so we include Office. We automate the installation of Office for you, so you don't have to really do much in order to get Office on the machines. But if you wanted to include like Chrome, or you wanted to include like your content filter or something like that, there's a CMD file called install apps in sysprep.cmd. That file, you will edit that file, and you make an example entry like this. What the file looks like in Notepad is effectively this. So you just a bunch of remarks in here to just comment out some things. So it makes it easier for you to know what's happening. But in here, like if you had like I've got Contoso app example, you would just rem out the following line that has the MSI exec command, and that's going to go ahead and do your installation of the application silently. And so with that, I think the last thing here is command lines, and then we'll get into the demo. So in order to run and build the FFU, it's a PowerShell script. This is just the command that we're going to be running here in a minute, and this will actually go and create the FFU. So how do we do this? How do we get access to all this stuff? So let's hop over to GitHub. So at my GitHub, I have uploaded the FFU development folder and all the content that's associated with that. So if you click on code and go to download zip, you could clone if you want. If you use GitHub, or if you use anything else, you can go ahead and just clone the Git repository if you want. If you aren't familiar with any of that and you just want the files, then just go to download the zip, then go ahead and save it. And once you save it, it'll go in your downloads folder. What I've found interesting recently is that I don't know if this is just a thing with Edge now, and Smart Screen is being a little bit more aggressive than normal. But when I start to download stuff from GitHub, now at least my stuff, maybe it's telling me something, but when I'm downloading from here, it's basically just telling me that, hey, the thing that you're downloading is not common. Make sure you trust it. It's not a problem. Go ahead and just click on keep, and then show more, and then keep anyway, and that'll allow the download to take place. And then once you've downloaded it, you will then go to your downloads folder, and then you'll want to extract the FFU development folder. Copy this out, and then I recommend in the documentation, copy it directly to the root of your C drive. You can customize this if you don't like doing that. If you've got a separate hard drive, you can definitely do that as well. And so once you've downloaded the files, you have it all extracted here. Now you've got access to everything that we need to actually start building. Now on this machine, I've already installed the ADK. I've done the test signing stuff. So if I go to let's go to my desktop here. Actually, I'm going to pull up the doc. Let me pull up the doc here. So this doc is in the docs folder, as you just saw me open. This is the complete documentation on how to do all this. So it explains that you need to install Hyper-V. Also, everything that I talked about with the Windows Insider ADK. All of the information is here, where to get it, where to download the ADK, how to install if you've never done that before, what you need to install. You only need deployment tools. You actually don't need any of the other stuff within the ADK, so it's a fairly quick install. But you also need the Windows PE add-on. And so don't forget that. I don't have screenshots of that, but you need to download both of them. So make sure you're downloading both. And then I mentioned in here that if you're using a non-Windows Insider build, here's the steps to, you got to disable secure boot, and then you need to make sure that you turn test signing on. And once you've done that and you've rebooted the machine, you should see on your desktop that you're in test mode. And then once that's happened, then you're in the right spot. I do recommend, though, that after you do this, we don't want to be in test signing forever, and you don't want to have secure boot turned off forever. This is not a secure way of doing things. I completely understand that, and I don't recommend it. But what you should do is, after you've done this, the best thing for security here to make sure that we turn off test signing and that we re-enable secure boot. And again, this is only temporary until we get the ADK completely released. Now, if you're running Windows Insider builds, test signing or flight signing is already turned on. So if you were to open up BCD Edit, you would see flight signing as yes, if you're on an Insider build. If you're not on an Insider build and you ran this, you actually won't even see flight signing at all. It's not even going to be an option in here. So if you're on an Insider build that flight signing should be on, you should be able to install the ADK, and you shouldn't have any errors when you're running DISM. So wanted to point out that the docs are here, so you can go ahead and run through those. And if you've got any questions or something's confusing or not working right, feel free to reach out to me. I'm definitely want to help out, make sure that this is working for anyone that tries it out. Okay, so we've extracted the repo from GitHub. It's now on our machine. We now need our media, and so I've downloaded the media already from the media creation tool. It takes a little while to do it, so I didn't want to waste the time. So I've got this Windows 11 ISO here that I'm going to use. I made it, yesterday? Yeah, yesterday evening. So I'm going to cut this and I'm going to just move it. I don't have to move this. I could keep it where it is, but I'm just going to try to keep things all contained here. So I'm going to paste that there. And then we're going to run that command that we saw earlier from the PowerPoint. So let me just grab that. Actually, I already have it. Okay. So let's just explain the command line real quick before we kick it off. So what we're doing here is we're passing the ISO that we're going to use to install. We're telling it which SKU to run. So in this case, it's going to be Pro. For 99% of you, it's probably going to be Pro. You might be using Pro Education. If you are, you can do Pro_Education. We support that. We support all the SKUs, really. I mean, you can do anything that's going to be in the consumer media, so Home, Pro EDU. You can image with all of those. That's fine. But now there's this switch here called Install Apps. So when I have Install Apps configured, what it's going to do is it's going to create a VM. And so that's why Hyper-V is necessary here, is that we're going to create a VM. And that VM is where we're going to put, we're going to lay the ISO down, and then we're going to install Office, because I've specified Office is true as well. But if I also, in apps, if I modified this, so if I modify this file to include additional apps, like again, I could put a folder in here for Chrome, and then I could have my Chrome MSI file here, and I can add the Chrome command line here as well. And I could do that for a bunch of apps. I could just keep adding, one after the other in this list, kind of like a task sequence. I've got all my applications that I want to install. They're all going to install silently. I could do that as well. But if I didn't want Office, like maybe your students don't use Office, maybe they all just use Google Workspace. If that's the case, then you don't need Office. You could come in here. You can actually come into the command line and say, I want to install apps because I want Chrome on the machine. I want my content filter. I want all these other things, but I don't want Office. And so you could set install Office to false because I don't need it. I want to save the space. I don't want to confuse the kids and have some things there that we don't want. And then it'll install your third-party apps, but it won't install Office. And then also we're going to install drivers. And so I don't have the folder here, or I have the folder here. I don't have my drivers here. So if I want to include my drivers, let me go. I don't have them. One sec. I don't want to restart. Okay, well, let's just pretend I had drivers. So in here, what I would do is in my drivers folder, I would put in here, I would have my Surface Laptop Go drivers, and I would have those there. And so the FFU will then just copy that in. And so those drivers now will be added to the FFU. So in order to run this, I need to turn that to false. I lost my drivers folder. Change that to false. And now we get into the VM information. So your virtual machine that you're building, in order to copy the FFU out, we need to copy it back to the host machine. And so the way that we handle copying the FFU to the host is that we basically are creating there's a share that gets created. It's a temporary share, it goes away. It's explained all in the docs. But we need the VM switch information to turn on the VM switch at the time that we're doing the capture. We need network connectivity. We actually don't create the FFU with network connectivity at all. And there's no network whatsoever. So we install Windows, we install your apps, we install Office, no network at all, because we don't want Windows updates. We don't want any of the built-in Windows apps to start installing or updating or any of that kind of stuff. So it's a completely offline installation of Windows in order to capture the FFU. But we do need network connectivity after the FFU has been, or after Windows has been installed and the apps have been installed, in order to actually do the capture. So we need the VM switch information and we need the IP address of the machine. And so you'll have to find these on your own. The script doesn't automatically do it. I looked at different ways of handling that, but what I couldn't guarantee was that you didn't have multiple switches and multiple IP addresses. And so it was hard if there were multiple IPs to know which one to use. So I just decided it's best if you just put your switch information and your IP information here. This all can be done with code. It's just that it's hard to understand what everyone else might be doing with their machines in terms of VM switches and stuff like that. So you would just need to put the switch name and then the IP address, and then we take care of the rest. And then lastly, we create capture media. And so the capture media is what we mount to the VM after Windows has been installed to do the capture of the VM into an FFU. And then deployment media. The deployment media is what actually goes on your USB drive. And so you need to create that, and then we will build the USB drive for you. So if you've went through this process with us in the past, you probably remember that you had to put a USB drive in, you had to manually do the partitioning, and it was kind of complicated to do. We handle all of that now. So you literally run this command, and I don't have my USB drive here. I'll stick my USB drive in the machine here. And this will generate the VM, creates the FFU, does the whole process, and then it creates your USB drive. And so all you got to do is take that USB drive out, plug it into a machine, and boot off of it, and it's ready to install Windows. It's really that simple. So let's go ahead and run this. Now, this is going to take me 20 minutes to run. So we've only got 20 minutes left in the call. So we're probably like right at the end of the call, this thing should be finished running. I'm going to go back to slides because right now what it's doing is it's going out to Office, and it's going out to the internet. It's downloading the Office Deployment Toolkit, and then it's doing the download of Office right now. And so Office is downloading. And if you wonder, hey, how do I customize Office, which I didn't kind of get into, if you want to customize Office, there's a deploy FFU. It's in the documentation on how this all works. But in the deploy FFU.xml file, that's where you would customize that. All right. So it did the Office download fairly quick, and then it built an ISO file here. So this app's ISO, this is where we actually put that Office download once it's done, and all of your other apps are included in that as well. So this then gets mounted to the virtual machine. I'm going to close that. And once the virtual machine gets built, which right now we're building the partitions, so we're doing the system partition, MSR partition, OS partition. Well, once the OS partition is built, we then start copying Windows. So we're copying our install Win directly to that drive. Once that's done, recovery partition gets created, and then it boots into the VM. So again, this is going to take about 20 minutes to finish. So we'll let that cook. And while that's doing that, I'm going to actually move back over to the slides to just talk about the deployment. So pretend that all of this stuff works just fine. We'll talk about the deployment, then I'll do a demo of what the deployment looks like. Okay, so when building, like I said, the USB drive is made and it's ready to be deployed. So as soon as that script is done, I'll have a USB drive that's fully ready to put into a new machine, and I can just go. However, there's no customizations to that outside of just the applications and what you would have modified in that CMD file. There's no other additional customizations that have been made to the USB drive itself. So things that we can add to the USB drive. I talked earlier about device naming. We can copy in an unattended XML file. And that unattended XML file can have your device name information, but you can also include other things as well, like the time. How many times have you dealt with imaging a Windows machine or just getting a Windows machine out of the box and the time was wrong? And that caused problems enrolling to autopilot. Happens to us all the time because these machines, their time is off because they've been sitting in a warehouse for so long. The CMOS battery might, just be going bad or something. And so that the time's off. It's not the time zone, but the time itself is actually off, and that's what's causing some problems. So we can add those things to the unattended XML. And so what I typically use the unattended XML for is naming. So that way I can name the device while the FFU is being applied, and I can save myself a minute per device. And so if I'm working with a distributor partner that's deploying 20,000 devices, 1 minute per device is 20,000 extra minutes that team that's doing all of that imaging work has to wait. And it's too much. If it's just you and a single device, you probably don't care. But if it's 20,000 machines, that time is significant. Now, what we can also do in this unattended XML is that we can actually have multiple name prefixes. So imagine you've got this USB drive and you're like, hey, I manage like 10 different school sites. I want to name things based on the school site. And so my name prefix might be, school site 1, school site 2, school site 3. And so I can have a text file in there with all the different name prefixes. And then when I go to image, if the script will see, oh, you have the unattended XML here, you've got this prefixes file. I noticed that you have like 10 different prefixes here. Which one do you want to use for this device you're imaging? And you pick the prefix and then it goes. So there's no manual typing. you just go ahead and use the prefixes. And so it makes it a lot easier so no one's like mistyping things. And then the drivers. So I mentioned earlier that if you don't include drivers in your FFU, which I'm not in the one I'm capturing, and so if I wanted to use this FFU with different models in my environment, I might have laptop Go 2s, I might have laptop Go 1s, I could have Surface Books, I can have all sorts of different devices. And if that's the case, on my USB drive, I can make a folder called drivers, and then inside of that, subfolders for all of my models. And then I'll just put the drivers in there. And then I'll be prompted if I have multiple models, just like the multiple prefixes. If I have multiple models, it'll ask me, okay, which one of these do you want to use to install the drivers? And so I'll go ahead and pick, whatever that might be. And then lastly, provisioning packages. Some of you might be using multiple provisioning packages just for device naming. I know I've seen some customers that had 50 provisioning packages, and I asked them why they had 50. I knew the answer, but I was just kind of curious to hear what their answer was. And they said, well, we've got 50 different device names that we use for everything in our organization. We've got namings for faculty devices, staff devices, student devices, different locations, labs, all, you name it. And so because of that, we have to create multiple provisioning packages. We're not using autopilot. And so because of that, they have to recreate these provisioning packages every 6 months. So if you had 50 of these, every 6 months you're making 50 new provisioning packages because the bulk enrollment token is expiring. So by including the device name inside of this method, now all I need is one provisioning package. And I don't include the name in the provisioning package at all because I'm naming it in the unattended XML in the prefixes file. I name it there. And so if I had 50 names that I was using for my provisioning package, I can take those 50 prefixes and I could put that into the prefixes .txt file. And that'll actually allow me to pick the name I want, the prefix I want, and only manage one provisioning package. So every 6 months, I only have to update one package, not 50. And so how do we do the deployment? So back to my Hyper-V instance here. So what we're looking at now is the VM is just building. It's in audit mode right now, and it's installing Office. Now, if I had my other apps, they would start to install afterwards. And so, you're basically seeing it build in real time. And it's now going to sysprep generalize, kick me back to Ubi, and then it'll shut down. And then once it shuts down, then it's going to start doing the capture. And so while that's still cooking, we'll just kind of keep that off to the side. And what you'll notice is that the script is just waiting for the VM to finish. It's built the capture ISO. So when this is done and it shuts down, the capture ISO is going to be mounted, and then it's going to start to do the FFU capture. So it'll have Office, have Windows completely up to date. You'll also notice it's not on the internet, like I mentioned earlier. There's no network connectivity. So updates, UWP apps, all that stuff is not getting in our way. It's just completely offline and building what it needs to build. And so when we do the deployment, because we only have about 10, 12 minutes here, to do the deployment, let me shut this guy down. It's turned off. When you're deploying a USB drive, let's see. You'll basically have a drive that looks like this. Try to plug drive in there. So you'll have a drive that has a boot partition. This is just PE, that's it, nothing special. It's a modified version of PE because there's a PowerShell script that does the automation of the installation of the FFU. But outside of that, it's just PE on the boot partition. And then on your deploy partition, I've got some extra files here. You won't see all of these. What you will have though is you'll have your FFU file, and then you can optionally create a drivers folder, an unattend folder, and a provisioning package folder if you have multiple packages that you want to deploy. And so what I typically see is, let me just modify this, is that you'll have drivers, keep logs there, unattend, And if you're using provisioning packages, you'd have a PPKG folder here. You don't actually need you really don't need this folder now if you're doing the device naming, because if you only have one package, you could just put it on the root of the USB drive. You don't need to put it in this folder. So like here, I've got 3 different packages here. So if I were to put this into a machine and start to image with it, it'll ask me which of these 3 do I want to use. But nowadays, most of you probably won't need this folder. We did need it in the past when I didn't have the actual device naming. But how the device naming works with the unattend is that there's this prefixes text file. You don't really need to modify the unattend. In fact, if you look at the unattend, it's very basic. It's really just, here's the computer name. Now, if you wanted to add different components like time, like I mentioned earlier, you can do that. It's supported. It works. But here it's very, very, very simple unattend XML file just to handle the name. So how that works is that it reads the prefixes.txt file. And so this is where I can put like, student, back, lab. Okay, the VM's done here. Lab. So I can go through and I can add all these different prefixes, and the script will actually ask me, okay, I see 4 of these here. Which one of these do you want to use? Then you just select the prefix and then you're good to go. And so the naming happens early in the process. And so again, we don't need to reboot to apply the name. So in Autopilot, in your profiles for Autopilot, you have a name template that you put in there. When that gets applied, a reboot happens. In provisioning packages, you put the name in, a reboot happens at ubi. Once the provisioning package gets consumed and it starts to run, it's going to reboot the machine to apply that name. So this applies the name before all of that, so you don't need to do that reboot. And so again, that prevents you from having multiple provisioning packages. And then for your drivers. So I mentioned if you have multiple drivers and you wanted to make this USB like a dynamic drive, so I can put this in any machine and I can pick the drivers I want, and it'll copy the drivers, then you can go ahead and do that. And so I've got my Laptop Go 1 drivers here, and then I've got my Surface Book 2 drivers here. And so it'll recurse the folders, it'll copy them all into DISM, and then the machine will be imaged. And so that's what your USB drive will look like after this process is done here, probably about 8 minutes. Oh, actually. Oh, did I? Okay, I think I've got another image mounted here when I was testing this earlier. But what? Okay, so it didn't actually image it. So going to. Okay, yeah. So here's the FFU file. So it cut the FFU, but then it was trying to mount it, and I think because I mounted another FFU earlier, I think there was some conflict there. So apologize for that. But what should have happened is that once the FFU was made, it would optimize it, and then it would create the USB drive. So unfortunately, I don't have the USB drive. I have my drive here, and it was supposed to format and all that, but it never got to that part because it had that issue with that other FFU that I had mounted. But it cut the FFU. And so when it did that, it also removed the VM. There's an underscore FFU and then some random numbers. That VM is gone now. It's deleted that because it's completed what it was supposed to do. So the FFU now is here. And then so you can take this FFU, copy it, and then put it onto your deploy drive. And then I could go ahead and image with that FFU if I wanted to. So that's been done. And so what that looks like when you're deploying this to a machine is that I built a VM here that basically mimics what you would see on a physical device. And so if I just have to reset some settings here on this. DVD drive. Okay, so we got hard drive there. Okay, we should be in good shape. From DVD. Yep. All right, let's get this going. Okay, so what this is going to do is it's just going to boot off of that ISO. So this looks exactly like what you would see when you pop that USB drive into a physical machine, and then it just rips. See how fast that this thing's going to apply the image. Now, to be fair, this is a VM. This is a fairly quick Hyper-V host. I'm just running Windows 11 on this thing, but it's a fairly quick machine. However, this is just laying down Windows real fast. I don't have any drivers. I don't have anything else that have been specified on the USB drive. So it just laid down the FFU just as is. But if I did have drivers, I did have different models, or if I had the device naming and I had different like device name prefixes, then it would prompt me for that stuff. And so at this point, there's nothing. This isn't really all that interesting at this point because it's just regular Windows installing. There's nothing fancy here. This will eventually get to the first screen of Ubi, and then at that point, if you were using something like Autopilot Self-Deploy, which we actually have a few large customers actually that are taking advantage of Autopilot Self-Deploy for this school year. And what we're finding is that by doing this method to get the FFU laid down and then going into Autopilot Self-Deploying, the machines are just flying through. Oftentimes in the past, if you used Autopilot Self-Deploy or pre-provisioning, or white glove as it used to be called, you may have had issues with TPM attestation. Those issues, and you might actually run into those issues even now with current builds of Windows on that are being shipped, particularly on Laptop Go 2. But we're also seeing, I think, with other OEMs as well, that the media that was released last summer for 22H2 for Windows 11, that media actually has a bug with TPM attestation. And so we're seeing, in some cases, a fairly good chunk of those devices are having TPM attestation failures. Those were fixed in September. I think it was the September CU for Windows 11. That when that CU was released, that fixed those TPM attestation issues. And so we're finding now with customers that are going through this process with the latest builds of Windows 11 that they're flying through, self-deploying. Success rate is high 90s. I think I've seen, like, in 120,000 device deployment, we've got maybe one device failed on TPM attestation. Everything else seems to be going pretty well. So we've got a nice, good, smooth, clean process that's going through. And it's been working pretty well. And so with that, we've got 3 minutes left, and I see Teams, and the icon here is pink. What do we got here? All right, probably a ton of questions that I probably can't answer in 3 minutes.
Richard, do you want me to go and pull them up?
Yeah, I'm looking at my other screen here, but I don't know what's been asked and what's been answered. So
let me start with let's see. Yeah, because there were quite a few.
Yeah.
Should they do a reference machine to the exact model, not a VM? What's your guidance there?
That depends. So if you've got like the same model across the board, it's not a big deal to just capture your own. This process won't do that though. This process is going to do it's going to do a VM, or if you don't need any third-party apps or anything like that, you don't need Office, you just literally want the FFU. If you have install apps that switch, if that's set to false, then we just capture an FFU. But if you're doing that, like I said earlier, I think like the media creation tool media, or even just I think media from VLSC, it's pretty fast now. It's faster than it used to be. I don't know. I don't know exactly what's changed, but in the past we would compare FFU to WIM, and FFU was always faster, and significantly so. Now it's getting pretty good between WIM and FFU. So if you're just trying to lay down Windows and you don't care about the third-party stuff, then you might just be better off not even worrying about the FFU. But if you are looking at like including Office and other apps and stuff like that, and you want to do like the device naming, you're looking at trying to create just like this like a dynamic little USB drive with different drivers, then what I showed you is probably going to be better. You're probably going to be better off than just using just regular install media.
Here's one more question. What's the best way to handle drivers for multiple models, individual FFUs, or for each type?
I think I'd probably spend about 20 minutes just talking about that. But yeah, if you have the same model, then you can just bake it into the FFU. So like what we're doing with these large scale deployments, it's all the same model. So if we've got 20,000 machines, it makes no sense to just have individual driver folders on the USB drive and have a technician pick them. It's always best to include them in the FFU because you don't have to wait for the copy for those devices. But if you have lots of models, then it's best to not include any drivers in the FFU at all, and have them on the USB drive like I showed in the demo.
Okay. Yeah, I think that's got most of them. If anybody else wants to come off mute for just a moment and ask a question out to the group, please do so.
Yeah, we could stay over a little bit if people have questions. I'm fine with that.
Hi, Richard. This is Joel from Calvert County Public Schools. I have been using this method for about a year now, and it's just been a game changer. I really appreciate everything here. The PowerShell script that's part of the boot drive. How often does that get updated? Do I need to worry about do I need to go out and get the newest one, or can I continue to use the one from a year ago?
No, you'll want to get the newest stuff from the GitHub share. So this will make all of that stuff for you now. So you don't have to, it's going to create your WinPE for you. It'll create the FFU. It creates everything. So best thing right now is to start fresh. I wouldn't use any of the old stuff, and just use what's at the current GitHub share.
Okay, thank you.
Mm-hmm. Let's see. So Bryce asks, I assume that unattended file gets created dynamically at runtime, building the computer-specific computer name by concatenating prefix. Yeah, it actually, yeah, Bryce. So it's concatenating the serial number. So it's really no different than something like autopilot or your provisioning packages. You could, like, if you wanted to modify it, I could modify it too to make it to prompt you for a name if you wanted something like that. Because I know some people like, typing names in. The intent, though, originally wasn't for that because it was really more so for like these larger deployments. Even if you're just doing like hundreds of devices, like the last thing you want is to have to type in a bunch of names. But there are some use cases for it. It's just not coded in for it right now.
Yeah, I think what you did, it sounds like you hit the base case pretty well, providing the extensibility to add in your own desired prefix list and then prompt the tech to pick one of those and then just concatenate the serial number on the end. That's perfect. I think that would make sense in almost all cases I can think of.
Yeah, and it's also truncating it too. So because what we don't know is we don't know if you're going to hybrid join these machines, and if you do hybrid join them, then you've got the 15 character limit due to NetBIOS. So you can't go over that. But if you were doing like an Azure AD join of a machine, Azure AD join machines can actually have 63 character names. So we'll concatenate the name down to 15 characters. I'm sorry, I won't concatenate. We'll truncate the name down to 15 characters if your serial number happens to make the prefix plus the serial number to be too long. We'll just make it 15 characters. So.
Richard, I'm sorry, this is Joel from Calvert County again. With the new process, I just want to for clarification. So with the old process, I was able to get in there and do things like customizing the basically the default profile, moving stuff around that we can't do necessarily with Intune or that I may not want to do with specific PowerShell scripts or something like that. But I can kind of set and hide certain things so the default profile we use in the copy profile is set and then capture the FFU. But with this new method, I don't have that flexibility anymore. Is that correct?
I don't know that you had. Well, I didn't intend for you to have the same flexibility that you're talking about either. Unless you modified the FFU on your own manually.
So I would boot up the ISO, basically install Windows on a VM, install everything that I needed to, and then make my changes, capture the FFU, and then.
Got it. Okay. Yeah. So the process I released like 2 months ago with were you manually making the VM? Okay. Yeah. that you can still leverage that process if you wanted to make those changes. Alternative to that, though, what you can do is in here under apps. It's really not an apps thing. Sorry, but what I would do here, like I like removing all the built-in apps that no one wants, like Xbox and Skype and all that stuff. So what I would include here is actually those things as well. So I'd have like scripts that would run to pull things off. And I know you're talking about swapping out like the default user profile or stuff like that. If you knew the command lines to do that, then I would put that stuff here to automate that, so you don't have to manually do it every time you wanted to create it. And so if you knew what that command line was, then you could just put it in here, just like you would like a task sequence if you were building this with MDT or SCCM.
Okay, I'll play around with it and see what I can come up with. Thanks.
Yeah, if you have problems with it, let me know, because it might be useful for others too. And if we've got something there that people can take advantage of, we can figure out how to automate. All this stuff can be automated. It's just a matter of figuring out what it is you're trying to do. All right. Any last questions before we wrap up? We're over a bit, but I hope this was useful.
I had a quick question, Richard.
Yeah, sure.
It's Joe from BU. Are you able to run PowerShell scripts instead of like MSI packages during the app installs? Can you have it do custom scripting or?
Yeah, so if you wanted to include in here, like I've got a PowerShell script I want to run, so like do PowerShell and then you'd probably do bypass, and then whatever the script is, that would work as well.
Yes. And during this process, you said it's not connected to the internet. So if any of those PowerShell scripts are grabbing dynamic installs of like latest version of Chrome or etc., it wouldn't be able to do that.
It wouldn't be able to do it by default, but you could, if you wanted to modify the script, you could have your thing connected. You could have your VM connected to the internet if you wanted to. I just don't do it because we've seen issues with sysprep in the past.
Yes.
When you capture an image and it, you get sysprep failures because of the inbox applications are updating.
Yep. Yeah. I've run into that a bunch with sysprepping VMs for Azure. So.
Yeah. So we just avoid it at all costs if you can.
Yep. Okay. Sounds good. Thank you.
Yep. No problem. All right, folks. Well, we're over. Hope this was good. The recording is going to be up whenever Scott or Garrett do it because I'm not doing it. But everyone have a great day. And we will see you all next time. Take care.